In today's video, you're learning about integration with partial fractions. Now, in order to do integration with partial fractions, right, let me first write down an example of integration with partial fractions. So 3 times x over x plus 2 times x minus 4. Now, in order to do this, we would have to convert this type of integral into an integral such as this. And I'll explain the reason in just a second. Yeah, so a over x plus 2 plus b over x minus 4. Now, as you can see here, if we times a over x plus 2 with x minus 4 on both the numerator and the denominator, and we do the same thing for b over x minus 4 but with x plus 2, we're gonna get the same expression here on the left side. But the problem is we have to first find out what a and b really are, right? And the reason, and yeah, just to be clarified, a and b are going to be constants. And the reason we want to convert it into this type of integral here is because, well, what is the integral of 1 over x plus 2? Well, that's easy. It's just ln of absolute value of x plus 2 plus c, of course. So that's why, right, we're taking this really looking complicated integral and turning it into something more simple. Okay, so that's the reason why we use partial fractions, is to simplify the actual integral. Okay, so yeah, so now let's actually solve for a plus b, or a and b. So in order to solve for a plus b, okay, so let me just show you how do we do it. So basically, right, as I said earlier, you times both the denominator and the numerator by x minus 4 for the first expression. Right, so we'd have some output like this. Plus b, oh, let me write that a bit better, plus x minus 4 times x plus 2. Okay, so now what do you notice here? Oh, hold on, I think, yeah, forgot this x plus 2 here. Alright, so yeah, what do you notice here? Well, one thing I notice is that the denominators here don't really matter, because you could times all this by x minus 4 times x plus 2 right, on this whole thing here, and then you do the same thing here. And this whole expression, right, since all of the denominator would cancel out with the what we're trying to times it by, so then the whole expression here would just be a more simple one, which is a times x minus 4 plus b times x plus 2. So whenever you're doing this, don't just write out the denominator, because you're never going to know that it's going to cancel out by whatever you times it by. So you can just directly go to here. Okay, that's one trick you could use on your exams. So when we do this, right, now we want to sort of plug in variables. Okay, now I'll show you what that means. Now, when we plug in variables here, right, we want to be strategic. And what does that mean? Well, here, if you use x is equal to 4, what is going to happen? Well, this expression right here is going to cancel out. And that's exactly what we want. Now, why do we want that? Well, when we do that, we're going to have, right, plug in x for 4, we're going to have 12 is equal to, right, x 2 plus 4, right, is equal to 6. So 12 is equal to 6b. So then we can just solve for b, which is 2. So now when we solve for b, right, we can now just solve for a now. Now we do the same thing for b. We plug in -2 so that we can solve for a. So when we do that, we get -6 is equal to -6 of times a. So then a is just equal to -1. Alright? So now that we have both of our So now we have both of our a and b values. We can now write the integral, which is -1 over plus over x plus 2 plus 2 over x minus 4. And all I'm doing here is just writing out the values that we found for a plus b, right? And using this type of formula that we made before. So now, right, this is easy now, because all we have to do is just find the integral of -1 over x plus 2 plus 2 over x minus 4, and we already know how to do that because we just have to use the ln function. Okay, so when we do that, we're gonna have negative ln of x plus 2 plus 2 times ln of x minus 4. Okay, plus c, of course. Now, when we do this, well, we can actually write this in a more near fashion. How though? Well, we can, right, according to logarithmic rules, we can put the 2 as x minus 4 all raised to the second power. So when we do that, we're going to have x minus 4 all raised to the second power. Right, and then we have minus ln of x plus 2 plus c. Now we can write this for even furthermore, because according to our rules, when you have ln something of minus of another ln, you can make the expressions divide each other. Right? You can have this expression right here as the numerator and this expression here as the denominator. So when we do that, we're going to have x minus 4, and this is all according to our logarithmic rules, that's how I know how to do this, over x plus 2, yeah, don't forget your absolute value signs, plus c. So yeah, this is our simplified answer. Okay. Now, let's move on to the next integral. Okay, so this one we're actually gonna do a bit harder one. Okay, so this time we're actually gonna make use of our quadratics now. Okay, so x plus 1 times x to the second power plus 4 dx. Now here we have a x to the x squared plus 4 times x plus 1. Now, in order to do this one, right, we can't reuse constants anymore, because if you sort of think about how we're going to handle this x squared plus 4, we can handle this x plus 1 easily, because we can just put some constant such as a or b, right? A over x plus 1 or b over x plus 1. Well, we can't really do the same for x squared plus 4. So that means, right, a over x plus 1. Now, remember this, okay? This is an important rule. Whenever you have a quadratic factor, you have to go 1 under, right? Same thing for a linear factor. You're going 1 under the actual power. Yeah, so yeah, if you go 1 under the actual power here. So that's why you have the constant here, right? A, just a constant. Now, same thing for quadratics. You would have x plus 2 plus 4, right? Now, 1 under this would be linear. So, it would be b times x plus c, alright? And basically, if this was x to the third power plus 3, right, it would just be b of x squared plus c of x plus d. Alright, so basically, whatever power you have, you just kind of go 1 power under, and then you just write out your whatever 1 power under is. And make sure that you write this whole power out, because you don't just do b squared plus d. You need that cx too. So whatever the standard equation is for that power, right, write it out. Right, b of x squared plus d is not the standard equation for quadratic equation. B times x squared plus c x plus d is the standard equation. Right, so write out your standard equations, is what I mean to say. So when you do this, let me just erase all this. Right, so when you do this, as I said earlier, don't worry about your denominator anymore. So we're going to have a times x squared plus 4 plus b x plus c. Right, we're just finding the LCM here times x plus 1. Now, again, pick your numbers or x values strategically. Now here, a strategic value would be x is equal to -1, right? Because when you use x is equal to -1, this whole expression here is cancelled out, and then now we can solve for a easily. So when we do that, we're going to have 1 is equal to 5 times a, and a is just 1/5. Okay, so I'm just going to write 1/5 over here so we can keep track of everything. Let me just erase all this. Okay, so now we know that a is equal to 1/5. Okay, so we can rewrite this equation as x, so 1/5 times x squared plus 4, and then here's the part where we kind of have to factor now, okay? Because we've already done x is equal to -1, but we can't really make x squared plus 4 equal to anything, like any strategic values for that, because then you'd have bx plus c left. So now this is kind of the part where you'd have to, right? Okay, here's the rule, right? So whenever you can cancel some factors out, like here, right, x is equal to -1, do that, okay, and solve for the other variable. But when you can't, then you kind of force a FOIL, as in this case. Okay, so now you'd have, okay, so bx squared plus bx plus cx plus c. So here, we know that, we kind of know, okay, here's the thing, right? We know that b is going to be equal to, it has to equal to -1/5. Now, what's the reason? Well, whoops. The reason is because, let me just swallow this out too. The reason is because we have no x squared in the numerator here, alright? Everything here is going to be equal to 1. So then how exactly do we cancel out the x squared term? Well, that can only happen if b is equal to -1, since that's the only other x squared term other than 1/5 times x squared. So, right, we would have all this, okay? Now b is equal to -1/5. Okay? So, right, since b is equal to -1/5, we can now have this equation right here. Whoops, let me write that a bit better. There we go, okay? Plus negative this plus c x plus c. Okay? Now, c here has to equal 1/5. And what's the reason? Well, there's no x term here, right? There's no linear term x, which means that c also has to cancel out with -1/5 here. So that's why we'd have to use c is not equal to 1/5. Yeah, so now we have all our terms here, right? So when we do this, we're going to have 1 is equal to 4, right? This is out, c of x is out, 1/5 is out, 4 of 5 is equal to 4 of 5 plus 1/5, which is equal to 1. Okay? Now, I want you to try this by yourself, okay? I want you to, I'm going to make another video to solve this integral, but yeah, I want you to try this integral by yourself using all these values, and yeah, I'll post the answer to the link of this YouTube video. Thank you. And yeah, and also we know that I don't think I clarified this earlier, but we know this is correct because everything here adds up to 1, right? 4 over 5 plus 1/5 is equal to 1.